Hey everyone, in this video we will see the solutions of three problems A, B and C from educational round 156 of Codeforces. So we can first start with the problem A. So in this problem we are given an integer and we need to find three integers x, y and z. All of those should be distinct and should not be divisible by 3. Yeah, so for this problem we are given n and we need to find x, y and z. And these x, y, z should sum equal to n. Moreover, so x remainder 3 should not be equals to 0. Similarly for y and z. Yeah, so this is the problem statement. We need to find 3x, y and z. And if we are not able to find these x, y and z, we should output no in the answer. So how do we do this? So I just tried a few cases. For example, if n equals to 1, then there is no way that we can find three distinct integers which are positive and whose sum equals to 3. So if n equals to 2, in this case also it won't be possible. N equals to 3 is not possible, right? And n equals to 4 also not possible. N equals to 5 is also not possible, because if we give 1 and 2, then there will be 3 given to z. For example, let's say x equals to 1, y equals to 2, then z must be equal to 3, and here we can see that 3 remainder 3 is not equals to is equals to 0, which should not be the case. So similarly, we can try for n equals to 6. Here also we can try to find a solution by using a brute force method. For example, if x equals to 5, then there is no way we can distribute 1 into y and z. So if this won't work, x equals to let's say 4, then also y and z, we can't distribute 2 into y and z, so this also won't work. If x equals to 3, this is not valid because this is divisible by 3. Similarly, we can try x equals to 2. Now we need to divide 4 into y and z. So we can try 2 and 2, but these are not distinct. And what else we can try? So we can try maybe 1, but then 3 will go to z, which is divisible by 3. So for n equals to 6 also we can't find any proper solution. Now we can try for n equals to 7. Here we will see that after trying a few cases, we can see that if we put x equals to 1 and y equals to 2, then z equals to 4. All of these are not divisible by 3, right? So from this case we can assume that whenever n remainder 3 is not equals to 0, in those cases when we remove 1, when we remove 3 from this, still the remainder will not equals to 0, right? So this 3 we can distribute into 1 and 2, and third z will be equals to n minus 3. So this is one solution when n is not equal when n is not divisible by 3. So what happens when n is divisible by 3? What should we do in this case? So in this case we can see that we can try to see that, let's say x equals to something 3p plus r1, right? Y equals to 3q plus r2, z equals to 3 s plus r3. So what should we do here? So we can see that whole of this, if we do sum of these three, it should be divisible by 3. And so r1 plus r2 plus r3 should be divisible by 3, right? And we also know that r1 can be either 1 or 2. Similarly, r2 can be either 1 or 2, and r3 can be either 1 or 2. So for we can try to make combinations of these, whatever combination gives us this modulo 3 equals to 0, we will take that. So let's say the first combination, let's say we have 2 1s and 1 2. Second case can be we have 2 2s and 1 1. And third case can be 1 1 1, and fourth case can be 2, 2 and 2. So in this case the sum is 4, which is not divisible by 3, so we can't take these type of remainder. And in this case the sum will be 5, so we can't take this type of remainder because this is not divisible by 3. In this case the sum is 3, and here it is divisible by 3, so this is a valid case. Similarly in this case the sum is 6 and this is divisible by 3, this is also a valid case. Now out of these two, what case should we take? We can think readily in this case now, because like if we take 1 1 1, right, what would happen? We need to find some numbers whose remainder comes 1. So here like the smallest numbers will be 1 and 4. These are two distinct numbers whose remainder with 3 gives us 1. And for 2 we can think of 2 and 5. Now this will give us better results because this will leave the rest of the third digit more like better, because let's say if we decrease by a huge amount, in for example in this case 2 and 5, now n can become 0, n can become 0 early, but in this case this is the best case. So here n will become 0 in the worst case. For example, let's say n equals to 12. So if we decrease 5 from it, what do we get? We get 7. But if we have, let's say, 9, in this case if I decrease 5 from it, I get 4. For 9 it is not possible, because now we can see that 4 and 4 are not distinct. So the final algorithm will look like this. When n is not divisible by 3, in that case we will write answer as 1, 2 and n minus 3. And before this we also have like if n is less than equals to 6, answer is always no. Now if n is, let's say if n is divisible by 3, in this case the answer will be 1, 4 and n minus 5, and this n minus 5 should be greater than 0. We will check, we should check that it should be greater than 0 and should not be equals to 1 also, and should not be equals to 4. So yeah, this is the solution for problem A. Now we can see solution for problem B. Yeah, so this is a very easy problem. So here we are given like 4 points. One is the origin, right? There is a P point where we need to reach, and there are two lights like at point A and somewhere at point B. Now we need to find a W. W is the radius of these circles. So these are lights, and when we provide W, these will illuminate the area of W radius, like this. Now we need to like find a minimum W so that this person who is standing at O can go to P without facing darkness, right? So the whole way from here to here should be illuminated somehow. Now I can think of a solution where, like, let's say I try binary search in this problem. So what we'll do is we will try from 0 to, let's say the maximum is 4 into 10 to the power 3. So from here to here we will try binary search. Whenever we find a W, we will see if it is possible for him to go from here to here, and if it is possible we will take that answer and we will try for a lesser length, and if it is not possible then we won't take that answer and we will try for a higher W in that case, right? So now how can we say that this W is suitable or not? So we can create two cases. In case 1 we can check if both O and P both lie in the same circle, both lie in same circle. So if they both lie in same circle, in that case the this W is valid and we can take it as answer, right? In case 2 we can check when, let's say, O is present in some circle. This should be a valid condition, that O is present in any one of the circle and P is also present in any one of the circles, right? And there should be a overlapping between these circles. We can check that easily. Now if one of these condition is met, in that case we can say that this w is valid and we can take it as answer. Yeah, so this is the solution for problem B. Now we can move to problem C. Okay, so this is a little difficult problem. Now we can see, let's first try to understand how the problem works. Like what is the problem statement? So we are given a string s, and then we are given a position, right? And then like we need to find, there are some operations that we need to do each time, like finding the least lexicographical string and concatenating it at the end, and then finding the character at the position post. So let's try to understand it better. So let's say we are given a string cab, right? This is called s1. Now we have to do n operation. So n equals to length of the string s1. So here n equals to 3. Now we have to do 3 operations here. In first operation, what we'll do is from s1 we will like delete some characters so that s2 is lexicographically smallest. So in this case we can delete c here and we will get s2 equals to ab. Now we can delete one more character and we will get b. We can delete b and we will get a. Yeah, so we have to do these operations n minus 1 times. So first we are given s1 and rest of the strings we can find out using this algorithm. Now in this problem what we'll have to do, we have to create a big string which is the concatenation of s1 till sn. So it will be s1 s2 s3. In this case it will be c ab ab a. And then in the problem we are given a position and we have to find the character at this position in this string. So for example, in the first case position was given as 6, so we can count from the first character 1 2 3 4 5 6. So in this case the answer equals to a. Yeah, so this is the problem statement. Now let's see how we can solve this. Let's say I have a set at the end. First of all, let's try to find out like we can try to find out in which string this position gonna lie. So for example, in this case position is lying in the s3, right? So we can try to find that position first and we can do that easily using binary search. For example, the length of first string would be n, length of second string would be n minus 1, and similarly it will go up to 1. Length of the last string will be 1. Now we can see that we can try to find a string, like what will be the index of the string at which the position will lie. For example, the string came out to be this one, right? Now if we know that kth string will have the character of our answer, then we can formulate an algorithm here. For example, we can try to use a set. So what we will do is we will iterate from 0 to k, 0 to k minus 1 actually. So we will iterate k minus 1 times, and each time for 0 to k minus 1, for 1 to k minus 1, so this will be k minus 1 times. So each time what we'll do is we'll try to delete a character, and we will whatever character we delete we will put in the set. We'll like keep a set name as covered. It will denote the covered indices. For example, let's say if we delete this, then this, then this covered set will have these indices 0, this one 3 0 3, right? So now, so the simple algorithm that will follow here is we will try to like these are the characters, right? Let's say we are going from here to here and we find some character which is greater than this one, right? These all are like less than equals to, less than equal to, but this is greater than this one. So we will delete this character because that will give us the lexicographically smallest string in the for the next case, right? So we'll delete this character from here, and we will move our pointer back here for the next iteration. Now we will again go from this to next characters, and whenever we find that, let's say now this is greater than this, we will delete this and we'll move this pointer to this. Let's say if we are ever in a position that there is no character here, so we'll delete this and we'll move to next one in that case. So this is the simple algorithm, and whenever we delete something we can try to maintain it in a set. Now let's say we have find our set here. So what we will do is we will iterate over the string, what we were given in the input, and we will skip those indices which are in the covered set, and we will take those indices which are not in the covered set, and we will try to find the correct position for it, and whenever we find the correct character we will print it. So this is a very simple algorithm here. Now the main thing here is how do we do these operation first. So there is one thing we can do, like similar to linked list, we can try to maintain two vectors here. It is first is called next, second is called previous, right? And initially, like, all of the indices will contain pointer to the next index like this, and previous will contain pointers to previous indexes. And whenever we delete something, we will move this pointer to here and this pointer back here like this. So this will make these operations fast, so that we don't have to iterate over the deleted indices again and again. Yeah, so this is the solution for problem C. You can see my code, I will provide in the description. Yeah, so that's about it, guys. Thank you for watching, and please subscribe for more such videos.